All right, so let's dive into cognitive development in middle childhood. And of course, our first stop will be going back to Piaget's theory. So previously, in the topic of Piaget and his theory, we first have fully covered the sensory motor period of development, the first 2 years of life. This is when babies and toddlers are operating entirely based on sensing and exploring their immediate environment. So it's very hands-on physical exploration and also utilizing those senses that they have to develop cognitively. Enter the pre-operational stage. This is our last stage. So what are some things we remember about the pre-operational stage? General ideas or even just buzzwords. Hopefully words like centration, egocentrism, pre-causal reasoning, mental operations is something we introduced. Hopefully these things came to mind. Now mental operations is something that pre-operational child cannot engage in yet. Hence the term pre-operational. It's before mental operation. So we did introduce that term last time. So young children can think symbolically about things that aren't in front of them. That's a new development in this pre-operational stage, but they're not able to engage in mental operations. So now we've arrived at concrete operational development in middle childhood, 6 to 12 years or so. So now kids begin to engage in mental operations. They can coordinate their mental actions. So they can do more than just represent things mentally. Now they can start mentally combining and separating and transforming things in their mind. So really big development during this stage. So hopefully we remember that big idea of centration in early childhood. So young children, preschool aged kids, they tend to center or get fixated on one aspect of a whole picture, which is a big limitation they have in their cognitive abilities. So hopefully this rings a bell. So now school age children begin to decenter. So they start to notice, consider, and think about more than one thing at a time. This is their new superpower. So for example, they can consider both height and width of an object when they reason about it mentally. A young child would not be able to do this. They would only be able to reason about one of those two things, height or width. They can form categories according to multiple criteria. For example, if they're given a cluster of different colored shapes, somewhat similar to the image we see here at the top, they can now make piles of red circles, orange triangles, red triangles, blue rectangles. They can make piles of different, categories. They can consider multiple dimensions or categories. This is more complex than we might think. A young child would really struggle with this. They would only be able to focus on color or shape, one of those two things at a time. So they would maybe sort them by color, or they'd sort them by their shapes. They put all the triangles together regardless of whether they're red or orange, at least when they're working on that task at that time. They can only hold one thing in their head at once, one dimension. So concrete operational child would be able to successfully organize them in this kind of way that we see here. So a young child couldn't do this because they would center only on one attribute of something. So what is one ability that comes from this new superpower of decentration? It's understanding conservation. So conservation is the fact that children, or when children understand that certain properties will remain the same, even if the appearance changes. So when I say certain properties, we're talking about things like mass or number or volume. So you can see a lot of these are like physical properties. So kids start to understand in this phase that these types of properties won't change, even if the appearance of it changes. So there are a number of tasks to test kids' abilities with conservation. Among the more commonly tested ones are conservation of number and conservation of volume. So conservation of number, we can look at this top image here with the yellow squares all over, or rectangles. Looks a little overwhelming. I'm going to tell you right off the bat, you don't need to pay attention to all these little numbers and letters inside them. So these are cards. Let's pretend these are cards, right? And this top half of the image with these first two rows is trial one. So let's say you and me, we're sitting across from each other at a table. This top row was your row of cards, and this bottom row is my row of cards. Visually, they look similar, but if we actually count them, we can conclude that they are the same in number. They have 7 cards in each row, right? So that would be the first trial, just establishing that they are the same, they are equal. Trial 2 comes around. What I will do is spread my cards out a little bit farther from each other. So we can see a visual difference now, right? But if I were to ask you in this trial, does your row have more cards? Does my row have more cards? Or are they equal? What would you say? Hopefully and probably you would say they are equal. Why would you say that? What would be your reasoning? You maybe would say something like, all you did was spread them out, but it's still the same number. If we put them back in the way they were before, it would still be the same number. Nothing would have changed. So we would use some sort of reasoning like that as adults. And also that mirrors the reasoning of a concrete operational child. They would have a similar response as you and me in this simple task. Pre-operational child might have a different response. So a younger child below the age of 6 or 7, if I were to do this trial 2 with them, spread out my cards while their cards were like this, and ask them the same question, does your row have more, does mine have more, are they equal? A younger child, as you may have guessed, is probably going to say that my row has more cards. If you ask them why, you might be able to guess what they would say. Because it's longer, because it's bigger. They're looking at only the very obvious visual difference here. This row looks bigger, right, visually, but we know that the property, in this case, the property of number did not change. So these young kids, pre-operational kids would struggle with this task. They wouldn't get it correct. And their reasoning would be a very obvious feature of it. They're only looking at the overall size, how it looks visually. So a concrete operational child would be able to reason like you and me. We also have conservation of volume. That's another way to test this. It's not just number, but we can also test it with volume of liquid. So if we present them with 2 equal glasses, like the bottom image here, you see these 2 kind of smaller, shorter glasses on the left. Let's say we fill them both up with this red liquid, the same amount. And then once we establish that they are the same amount, once I ask the child, are these the same or are they different, and have the child agree that they're the same, then what we do is pour the liquid from one of these glasses into a taller, slimmer glass. Right in front of their eyes, we're pouring the liquid from the original glass into a new glass that's taller and slimmer. Again, pre-operational younger child is likely to say that the taller glass has more. And this is because their response will probably be, it's bigger, or because the liquid is higher, it's taller, or whatever it might be. They're only paying attention to the most obvious thing. Now, concrete operational child, in the phase we're discussing today, will say that they're the same. They understand that the amount of liquid has not changed just because the appearance changed, just because it looks taller in this glass now. So let's watch a short clip where 2 kids are engaging in this conservation of volume task, and I want you to pay attention to their difference in responses. I'm going to actually exit out so we can go full screen here.
Can you look at these 2 glasses? Do you think that they have the same amount of juice? You think they have the same? Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice, this glass has more juice, or do you think that they have the same amount?
That one has more.
This one has more, and why do you think that this one has more?
Because it's taller.
So first we're going to look at these 2 cups right here. Do you think there's the same amount of juice in this glass as there is in that glass?
They're even.
They're even? Okay. So we're going to take the juice from this glass and pour it into this one right here. Okay, so now we're going to look at this glass and that one. So do you think that there's more juice in this glass, more juice in this glass, or do you think that they have the same amount?
Same amount.
Okay, why do you think that they have the same amount?
Just because this is skinny doesn't mean It's not the same amount. It has the same amount of juice in it, but this one is just wider and this one's skinnier, but they have the same amount of juice in it.
All right, we'll stop there. There is another half of this video with a young child going through the number task and also a graham cracker task. And I would highly encourage you to watch that on your own later to further understand the difference between pre-operational, concrete operational child. But for the sake of today, we'll stop here. So as you could see, the first younger child was not able to reason about, in this case, the liquid, and realize that the liquid amount stayed the same, even if the appearance changed. So they only seem to focus on the most salient or obvious feature, in this case, the height of the liquid, which is, they'll always focus on something that's like longer or taller, something like that. Whereas the older child in this thumbnail here, they had some pretty complex reasoning about, well, first of all, they did say that they are the same. And then they had really good complex reasoning about why. I could tell they struggled a bit articulating, but they knew that the liquid was the same, but they were trying to articulate why they knew that. And they said something like, just because this glass is wider and shorter and this one is taller and skinnier doesn't mean they're different in the amount. It did not change. So that just goes to show this is a great illustration of the difference in how these kids are thinking. And these kids probably weren't that far apart in age, but somewhere in this transitional period from pre-operational, concrete operational, somewhere around 4, 5, 6, we start to see this transformation in how they think about tasks like this. So sometimes their responses will demonstrate some pretty complex reasoning like we saw here. And this idea of conservation stems from increased cognitive capacity to consider multiple things at one time. So decentration. This child could consider both the height and the width at the same time. And they said that we could see that in their response. So concrete operational development is not just limited to conservation tasks and the idea of decentration. There's a little more to it. That is a large focus, but we're also going to look at some other cognitive abilities that concrete operational kids show. So one development is attention, one big development. So kids can attend to more details now. They can attend to things for longer periods of time, and they can start ignoring distracting information. These are all some developments we see in the realm of attention abilities. So very, very big stuff going on here, as well as planning. So kids can now start forming cognitive representations of a situation and navigate through it mentally to achieve a goal. Pretty complex stuff. For example, games like Minecraft become more popular in school-age kids. Any kind of game that requires kids to solve logical problems, they have to think about not only their goals, but how they'll achieve those goals. And, we'll see school-age kids start gravitating toward logical type games or activities, including like puzzles, mazes, anything that involves logic and planning to exercise these new abilities they have. They like the challenge usually. So this stems back to the new planning abilities they have. Lastly, metacognition is another development here. So metacognition is the ability to think about our own thinking. So school-age children develop a better understanding of how memory works, how their own memory works, what are their own cognitive abilities. So they're able to be flexible in choosing strategies based on the difficulty of a problem or the content that's being learned. So they start exercising metacognition by stepping back and regulating their own thoughts. So those are some other big developments we see according to the concrete operational perspective. That is where we will end it here. So thank you for joining this portion, and I will see you as we continue moving along. Thanks, everyone.